class we saw about mirrors, isn't it? And we also learned about reflection, and we learned what is incident ray, reflected ray, and the angle and the connection and all those things, isn't it? Today you will be thinking, why teacher standing in front of the mirror? Yes, we are going to learn more about mirrors. So that I need a long mirror, that is why I am standing in front of the mirror here. So now we know we all use the mirror, isn't it? For what do we use the mirror? So that we can see ourselves in the mirror, isn't it? So this is called the mirror, which we use to see our face is called as a plane mirror. So this mirror is called as a plane mirror. Now I'm standing in front of the mirror. We are going to learn the peculiarities of a plane mirror. I'm standing here and I'm holding here. What can you see inside the mirror? How do I look inside the mirror? Am I small, looking short, or looking big, or looking fat? No, isn't it? When I stand in front of the mirror, you can see me in the same size. There is no change in the size, isn't it? You can see exactly me inside the mirror. So, the peculiarity of the mirror is that when we look, we can see us in the same size. But I am holding, this is my left hand. This is my left side and this is my right hand, isn't it? When you look at me, this is my left and this is my right. But when I look into the mirror, when I hold here, this is my left and this is my right. But what is the position of the mirror? From the mirror, when we look at the image, is it the left side of the mirror? No, isn't it? It is the opposite side. But I am keeping here, my left hand will come here, and when I am keeping here, my right hand will come here. So it is just the opposite side that you are seeing. If this is my left and my right, then in the mirror, this is not my right, but this is also showing the left hand, isn't it? Actually, it should be opposite, but it is. So this type of image formed like that, that is, our left is shown as left and right is shown as right only. That is called as lateral inversion. So one peculiarity of the plane mirror is lateral inversion. So because of this lateral inversion, plane mirrors are used in the vehicles. Why? Because lateral inversion happens. That is why you must have seen in ambulance, isn't it? Why is the letters written upside down from back to front on the ambulance? That is because in the rear view mirror, when we look into the inside the vehicle, you can see a rear view mirror, isn't it? When you look into inside that, if the ambulance is coming from behind, you can read it straight. So for example, I have written mirror from left to right in the opposite direction. But when I keep this near the mirror, I hope you can see it. Keep it near. You can read the mirror there inside, isn't it? So this is called as lateral inversion. Now, I am holding a pencil here. Can you calculate the distance of this pencil? Can you calculate the distance of this pencil? That is, the distance of this pencil from the mirror up till here is equal to the distance of the pencil from here up till here, because the distance, as I bring this forward, you can see here, there also the distance is increasing, here also the distance is increasing. When I bring it close, there also the distance is decreasing, isn't it? Here also it is decreasing. So we can see that in a plane mirror, the distance from the image to the mirror is same as the distance from the mirror to the image there. The object to the mirror, the distance from the object to the mirror is the same from the mirror to the image formed. So that is another peculiarity of a plane mirror. So what is one peculiarity what we learn? One peculiarity is there is lateral inversion. Then the distance from the object to the mirror is the same as the distance from the mirror to the image. So that is another peculiarity of plane mirror. So there are three peculiarities of a plane mirror. What are those peculiarities? First I told you the image is of the same size. If I hold a pen here, the size of the object and the size of the image is the same. So the image and the object, size of the object and the size of the image is the same. Then lateral inversion takes place. This is just the opposite of that. So lateral inversion takes place in a plane mirror. Then the distance from the object to the mirror is equal to the distance from the mirror to the image formed. So these are the three peculiarities of a plane mirror. Now you have heard about Aramula Kannadi, isn't it? Why do we use an Aramula Kannadi? It is because Aramula Kannadi is made in such a way that you get a very clear image. So that is mostly used by people to look at the face, because you get a clear image of yourself in an Aramula Kannadi. Now, I am showing you a steel spoon, a ladle. Okay. Now, this has got an inside curved part and outside it is curved. Isn't it? Now, you have to look at the image which is seen inside here and here. For that, teacher will come closer to the camera so that you will be able to see. And I will focus the fan for you so that you will be able to understand the difference between the two images formed here and here. Now I am holding the spoon in this way, the outside part of the spoon. Now look at the fan there. You can see a bigger view of the room, isn't it? You can see the bigger view of the room also, and you can see the fan clearly, isn't it? But it is a smaller image form. It is not like how you saw in the plane mirror. Now I am going to turn the spoon in this such a way. What will be you be able to see? Where is the fan now? Yes, you can see that the room is upside down, isn't it? The fan is down now. So what did you understand from this image formed here in the inside, where it is going deep inside? It is curved inside, the inside part of the spoon. So what did you see here? Here you can see that the image is upside down, isn't it? Inverted. But here you can see the image is erect, straight. But you can see a bigger view of the room. Here you can see that the image formed is upside down or inverted. When it is upside down, it is called as inverted. Here it is erect. Here it is inverted. I hope you understood the difference between the images formed. You have a spoon like this at home. Please take the spoon and look at it, a new spoon, and look at it and find out the difference between the images formed on a steel spoon. So I hope you have understood. So to do that experiment more clearly, you can take a cardboard piece like this, stick a silver decoration paper on top of that, and then there is an experiment given in your textbook, that is plane. If you keep like this, what is the image you can see here? I cannot show it through a camera. It is difficult. So look at this and find out the image what is formed here. Then you have to bend forward like this, find out the difference of the image. Then you have to bend backward like this and find out the image what is formed inside this after sticking a silver paper. Please do this experiment and write down your inference inside your notebook. Now, I have a ball here. Okay, I have a ball here. Now, I have cut the top portion of the ball. So, this ball is in what shape? It is a sphere. Isn't it? It is round in shape. It is a sphere. Now, I have cut open the top part of the ball. Okay. Now, the inside part of this is curved inside, and if you turn, this part is curved outside. Now we have mirrors similar to this. I have two mirrors with me similar to this ball, part of a ball. So if I take this mirror is curved outside. You can see this mirror is curved outside. And here you can see another mirror. This is curved inside. Okay. So if I keep it on a ball like this part is curved inside and this mirror is curved outside. So these are two types of mirrors which are available everywhere, which we use in our daily life. These two type of mirrors are called as spherical mirrors. What are they called as? They are called as spherical mirrors. Why are they called as spherical mirrors? Because when you cut a ball, you get a piece like this. This is part of a sphere, isn't it? So these mirrors also resemble a part of a ball, a sphere like this, because one is curved outside and one is curved inside. So because it is a part of a sphere, these mirrors are called as spherical mirrors. Now these two mirrors have got two names. What are those two names? This mirror, that is the reflecting, the back side does not reflect, only the front side will reflect. This reflected portion, if it is curved outward, this mirror is curved outward. This mirror which is curved outward is called as a convex mirror. It is a convex mirror. So what is the peculiarity of a convex mirror? The reflecting portion will be curved outwards like this. So if you touch this, you can feel. I cannot make you feel because you are at home. We cannot do anything. So this mirror is curved outward. So this is called as a convex mirror. And this mirror is curved inward. Okay, inward. The reflecting part is curved inward. This mirror is called as a concave mirror. So what is a concave mirror? When the reflecting part is curved inward, that is a concave mirror, and the mirror in which the reflecting part is curved outward, it is called as a convex mirror. So this is a convex mirror and this is a concave mirror. I hope it is very clear. Now we are going to see how images are formed in a concave mirror and a convex mirror. This is a very difficult thing for me to teach you because it is through a camera. It is very difficult for us to observe. But teacher will try the maximum to show you the images formed using a concave mirror and a convex mirror. Now children, this is a concave mirror. Now I am trying to focus the outside picture onto this paper here. It's not very clear, but still you can see the outside the scene here. You can see the scene which is outside through the window. I can focus it onto a paper. I know it is not very clear, but I will be able to show only this much. So outside picture here you can see on a piece of paper here. What is it? The trees and everything you can see here. So using a concave mirror, I can focus it in such a way that the outside picture can be focused onto the paper here. Now I am taking a convex lens. Okay, a convex lens here. You can see this fan inside the mirror here. But here in this, if I show, the real image you can see. Now I am trying to focus the outside picture here. But here we are not able to make any image here, isn't it? But using a concave mirror, I am able to bring the outside images here onto the paper. But using this mirror, I am not able to bring the outside images here onto the paper. So this is the main difference between a concave lens and a convex lens. So if I am able to focus the scenes onto the paper here, then this type of an image is called as a real image. But when I am able to focus the things onto this mirror, then this type of image which is formed inside the mirror, that is called as a virtual image. And this image which is made to be formed on the another surface, this type of image is called as a real image. And this image which is formed inside the mirror, it is called as a virtual image.
What you see on your screen is a mirror. It has this plane and smooth reflecting surface on one side. It's called a plane mirror because its reflecting surface is flat. When we stand in front of a mirror, we see an image of ourselves in the mirror. Nothing surprising there. Why are we able to see our image? Yes, it's due to the reflection of light. In fact, it's due to multiple reflections of light rays. How? The light rays from the source are first incident on our body. They bounce off from our body and fall on the surface of the mirror and again gets reflected from there. This reflected light then reaches our eyes and we see our image. So what does this tell us? Yes, this tells us that a light ray can get reflected multiple times. The same thing happens for every other non-luminous object as well. If you remember, my initial goal was to explain what virtual and real images are. Let me ask you a question. This image that you see here, is it a real image or a virtual one? This image is a virtual image. In order to explain what a virtual image is, let's first simplify this image. Let's represent this boy with an arrow pointing up. And here is our plane mirror. You can assume the top of the arrow to be the top of the head of a boy. Now, where is the image of the boy formed? When we see the image in the mirror, it seems to us that the image is formed somewhere behind the mirror. But there is nothing behind the mirror, right? For us, the light rays seem to come from the location present behind the mirror. For instance, consider a few light rays emerging from top of the arrow. All these rays are incident on the mirror and get reflected back. Yes, all the reflected rays will follow the laws of reflection. You see that all the reflected rays are moving away from each other, that is, they are diverging. But we know that the image is formed somewhere behind the mirror. So let me extend these reflected rays backwards and see what happens. We see that they meet at this point behind the mirror. And to us, this is where the top of the image appears to be. When we look at this point, it appears to us that all the light rays are diverging from this point. But in reality, there are no light rays behind the mirror. This being a smooth and shiny surface reflects most of the light back and almost no light reaches behind. But yet, we have the perception that the light rays are coming from the point behind. So we just consider the top of the arrow here. We can do something similar for the remaining points on the object to get the complete image. So we say that the image formed here is virtual, or in other words, not real. You can think of a virtual image as an image which appears to be formed in a position somewhere behind the mirror. but in reality, it isn't there. A virtual image is formed when the light rays diverge after reflection from the mirror. Every plane mirror forms a virtual image. This is the first characteristic of the images formed by plane mirrors. Images formed by plane mirrors are virtual and not real. So what is the real image then, and how are they formed? Let's replace this plane mirror with a spherical concave mirror. Why? It's because real images can be formed by concave mirrors. Let's consider the light rays from the same point of the object incident on the mirror. We see that after reflection, each ray is traveling in a certain direction. Note that here as well, each ray obeys the law of reflection. What difference did you notice here compared to the plane mirror reflection? In the previous case, all the reflected rays were diverging. Yes, here all the reflected rays after reflection are intersecting each other at this point, or we can say that they are converging at this point. And the image of the top of the arrow is formed at this point. And we can do something similar for the remaining points of the object too. We get this image. This is called a real image. It is the image formed when light rays converge after reflection from the surface. One important thing we need to know is that real images formed by concave mirrors are always inverted. You see that in this case, the image is formed on the same side of the mirror as the object is. Real images are always formed on the same side as that of the object, and light rays do reach this position. When we look at the real image formed by a concave mirror, it also seems to us that the light rays are diverging. But here the rays actually are diverging from a point in front of a mirror. Whereas in the case of a plane mirror, it appears to us that the rays were diverging from the point behind the mirror. So did you understand the difference between a virtual image and a real image? When we look at a virtual image, it appears to us that the light rays are diverging from a point somewhere behind the mirror, but in reality they aren't, as no light reaches behind the mirror. It's only our perception. And in the case of a real image, the light rays are actually diverging from the point present on the same side of the mirror. In reality, light rays indeed reach this point. Hence, we call it a real image. However, there is one more type of a curved mirror. Do we know what it's called? Yes, a convex mirror. So what is a convex mirror? A mirror whose reflecting surface is curved outward is called a convex mirror. The question now is, how does an image formed by a convex mirror look like? What now? Now let's keep the object at a finite distance from the mirror and try to represent the image formed for this case using a ray diagram. So how did we proceed? We only need to take any 2 points on the object which is represented by this arrow. Find out the image of these 2 objects' points first by drawing at least 2 rays emerging from each point. After reflection, all these rays will follow the laws of reflection. When we extend these rays backwards, we get our image locations. I repeat again that this is not a real location in space. It's only a location where the image appears to be formed. When the object is infinitely away from the mirror, we get a point-size image at the focal point. And as we keep moving the object towards the mirror, the size of the image keeps increasing and it appears to be coming closer to the backside of the mirror.
So here we saw 2 types of images formed, isn't it? We saw using a concave lens, I was able to bring the outside picture or the outside images onto a piece of paper. So that is called as a real image, and using a convex lens, we were not able to make any image. So that type of image is called as a virtual image. This type of image is called as a virtual image, and using a concave lens, the image which is formed is called as a real image. So this is the main thing which we learn in this. So this is a concave mirror and this is a convex mirror. A concave mirror forms real images and a convex mirror forms virtual images. I hope it is very clear. Now we know that this is a concave mirror and this is a convex mirror. Okay, now I hope you can see my face here. So in this convex mirror, what is the peculiarity of this convex mirror? You can see a smaller size of me inside the mirror, isn't it? You can see a smaller size of me inside the mirror. So here we can have a wide view of the room through this mirror. A wide view, and you can see a diminished form. It is not the real image as you look in the plane mirror. In the plane mirror, we can see the same size. But in a convex mirror, you can see a diminished size of the object. So, such type of mirrors are used in the rear view glass of a vehicle. Why? Because the diminished image is formed and a wide view also we get. But what is the difference between a concave mirror? If I hold the concave mirror very close, the image will be too large. Okay, the image will be too large. Now if I hold it very far away, you can get an inverted image. Here you can see I am upside down. When I keep it very far, you can get an inverted image. But when I bring it very close, you will get a zoomed image of me and I will be bigger than the normal size. Okay, so that is the difference between a concave mirror and a convex mirror. So we saw the differences between convex mirror, concave mirror and a plane mirror. So because of these peculiarities, these mirrors are used in different ways. So for example, a convex mirror, we saw that the diminished image, a small image is formed inside the mirror. A small image is formed. So this convex mirror is used by drivers in the vehicles so that we will be able to see vehicles coming from far. The drivers in the side mirror, you can see, if you touch it, you can see the mirror is curved outside if you have a car. So why do we use a convex mirror in a vehicle? So that a wider view will be got and we can see the vehicles coming from a distance in a smaller size. So that is why convex mirror is kept in a vehicle. Now, for example, a concave mirror. What is the use of a concave mirror? That is, we saw when you bring it closer, the enlarged image is formed in a concave mirror. When you keep it far, you can see the inverted. But when you bring it close, the real person will be enlarged. So, these type of mirrors are used in shaving mirrors. Okay, in shaving mirrors, these type of mirrors are used because we can get a closer view of our face, and also in a torch. In the torchlight, the reflector of a torch is a concave mirror because a zoomed image can be formed there. So these are the uses of a convex mirror, concave mirror and a convex mirror. Now why is a plane mirror used? Yes, plane mirror is used to look at our face in the normal mirror. To see our face, a plane mirror is used, and also it is used in a kaleidoscope. What is a kaleidoscope? Here in the textbook you can see a kaleidoscope. I'm not able to make it. You can try and make it. You have seen a rectangular piece of mirror joined together. You put bangle pieces in that and you can look through that. So you can see different designs there. So that is called as a kaleidoscope. And also plane mirror is used in a periscope. What is a periscope? A periscope is a type of mirror which is used in a submarine. That is, certain mirrors are arranged in such a way that the submarine is a vehicle which goes under the sea, we know, isn't it? To know the depth of the sea, to learn the things of the sea, and also during war, submarines are used. So periscope is a mirror used in a submarine so that we are able to see what is outside. The periscope comes out of the water. and we are able to see images which are outside under the water. So mirrors, plain mirrors are arranged in such a way in a periscope so that we can see the outside world even if we are under the water. So this is something which shows how a periscope works. Watch it. Experiment here. For that, teacher has taken a box like this. In this, I have kept one mirror here, and a candle is burning inside. Now we are going to see what will happen, because the experiment which is given in the textbook, it is not practical when we are taking the video of that. So I have arranged in such a way that you will be able to see something. I will be showing you, then you will conclude what you are able to see. Now I have arranged in such a way that two mirrors are facing each other. I hope you will be able to see. You can see many candles. There is only one candle here, but through the mirror, I hope you are able to see many candles burning. That is, multiple images are formed here. Okay, here multiple images are formed. That is, candles and candles, many candles are being burned here. So what is the peculiarity you saw here? When we keep two plain mirrors opposite direction, you can see that multiple images can be formed here. See, in a line, you can see many candles burning together. So this is another peculiarity of a plain mirror. So plain mirror is used to look at your face, and also multiple images can be formed there. Please try it out in your home.